Converting between rectangular and polar coordinates. Sometimes we have a point expressed in one form and we want to switch it to the other form. How can we do that? Well, the easy situations are the ones where you've got a point that's either sitting on the x-axis or the y-axis. You don't really need any special formulas or anything because you can quickly visualize what's going on. Here's a couple of simple examples. The first one says, I have something in polar coordinates. So this is the point r comma theta. That represents some location in the plane. And I want to write down the rectangular coordinate name. There will only be one answer here. There's only one rectangular name for any given point. As soon as I see the 2 pi, I realize this is really easy. I don't even need polar graph paper. 2 pi is such an easy angle. If I rotate around 2 pi, it means I'm still facing the same direction I was when I started. Right? I start at the positive x-axis. Rotating around 2 pi doesn't change anything. Then from there, I walk backward 4 spaces. So that would put me right out here to this spot. Here is the point -4 comma 2 pi, right? I had to walk backward because of the negative. I just want to write down the rectangular coordinate name for that point. Well, it's very easy. It's just x is -4 and y is 0, right? Left 4 and then don't go up or down. So visually, I have the answer. Here's another one. Let's try to go the other direction. This says we're starting with the rectangular coordinates this time. So this is an x and a y. And we want to write down the polar coordinate name. Well, let's plot the point. 0, 5 would be right here. I want to write down a polar name for that point. Unless the directions say otherwise, we'll just try to do the simplest thing we can. The simplest way to go would be to rotate around pi over 2 radians or 90 degrees in a counterclockwise direction. Then I'll be facing the right direction and I can just step up 1, 2, 3, 4, 5 units. Meaning my polar coordinate name would be 5. I walked 5 steps forward after rotating pi over 2 radians. Positive pi over 2 because we went counterclockwise. Here is the simplest polar coordinate name for that point. Okay, but what will we do if we have a point that's not on the x-axis or the y-axis? Well, there are some simple relationships that exist between the xy coordinates and the r theta coordinates, and it's pretty easy to see where they come from by drawing a picture. Here's a point in the xy plane. One way to describe how to get there is polar coordinates. This would be theta, and this distance would be r. But of course, there's our familiar way as well, where this horizontal distance is x, and this vertical distance is y. All 4 variables, therefore, are a part of this right triangle that I just drew, which means it's easy to use both geometry and trig to write down some easy relationships. The most obvious one would just be the Pythagorean theorem. I would have x squared plus y squared equals r squared. R is the hypotenuse of that triangle. And then I have my SOHCAHTOA relationships. I have sine theta is y over r, opposite over hypotenuse. I have cosine theta equals x over r. And I have tangent theta, opposite over adjacent, would be y over x. Well, this box shows how we usually remember these relationships. You can see the Pythagorean theorem and the tangent relationship on the left side. These two on the left side are useful if you want to switch from rectangular to polar. And that's because if you have the rectangular, then you already know the x and the y. Well, you could fill the x and y in to these relationships and then solve for r and theta. The other 2 equations in the box come from the other 2 equations we have right here by eliminating the fraction. So if I multiply both sides of each of these equations by r, then I end up with x equals r cosine theta and y equals r sine theta. These are the 2 equations that you want to be using when you want to go from polar to rectangular. If you start with polar, then you already know the r and theta, and you can plug those values in to obtain x and y. Let's try an example. I have polar coordinates here, the point 4 comma 5 pi over 6, so that's an r and a theta, and I would like to write that using rectangular coordinates. That means I'll be using this second set of equations, and I can really just plug in. The x coordinate would be r, the 4, times cosine of the theta, the 5 pi over 6, and the y would be 4 times sine of 5 pi over 6. Now obviously you'd have to pay attention. Do we want exact answers or decimal approximations? Let's do an exact answer. We can, because 5 pi over 6 is one of our nice values. I could draw a quick picture to get those values. Let's see, 5 pi over 6, that's over here in the second quadrant. It's 150 degrees. The reference angle would be 30 degrees. So I would have a 30, 60, 90 triangle, 1 square root of 3, and 2, whose negative. The x would be negative here in the second quadrant. Cosine of 5 pi over 6 then would be adjacent over hypotenuse, so negative root 3 over 2. And sine of 5 pi over 6 would be opposite over hypotenuse, looks like positive 1/2. And then I can carry out the math. I've got some canceling that happens in each case, leaving me with x equals negative 2 root 3 and y equals 2. And there's my final answer, negative 2 root 3 comma 2. As you're learning this, you want to draw as many pictures as you can. Let's visualize what we just did. Where would be the point 4 comma 5 pi over 6? Well, let's see. I would have had to rotate around counterclockwise until I got to that 5 pi over 6 spot, and then along that angle I would travel a distance of 4 spaces until I got right here. So here's the point we're talking about. Well, we're just saying that another way to get to that same spot, if you picture the x-axis and the y-axis drawn on here, another way to go would be start at the origin like you're used to, travel 2 root 3 spaces to the left. If you do that on your calculator, that's going to be around negative 3.4. So let's mark that down. 1, 2, 3, a little bit more, maybe 3.4. Negative 3.4 is somewhere right around here. And then from there, walk up 2 spaces. 1, 2 spaces. And you can see negative 2 root 3 comma positive 2 lands you at exactly the same spot. Thanks for watching.